Starting in our completed stabilization composition, we can begin the process of template match. Template match is a process similar to stabilization, where a topologically consistent segment of frames can be created from a source mesh, called the template mesh. Unlike stabilization, this source is manually specified as a particular keyframe or an external mesh. The template mesh can be a frame from the track you're editing, or a mesh imported from another clip. All of the operations that would be applied to a keyframe during the stabilization process will be made against this mesh. So if it's too different in form from the rest of the interval, your template match is likely to fail. In addition, you can manually specify the keyframe and segment size, which can help you take finer control of your result than a stabilization stage. We'll add the template match stage to our track and put some settings in place before we start adding intervals. If you open the parameters for the stage and scroll down to the bottom of the parameter list, you'll find a few template match specific options. The template mesh field allows you to specify the mesh to use as your template. In this tutorial, we'll be leaving this field empty. With no mesh assigned, you can set the template offset parameter by dragging the keyframe indicator diamond in your interval to choose what frame you use as a template. Alternatively, if you're using an external mesh as your template, you would drag an individual mesh from any clip in your project view onto the template mesh field to use that mesh as the template instead, ignoring the template offset setting. Most of our settings are going to stay true to what we'd established in our stabilization stage, but we'll try a bit of a tighter alpha point to see if we can continue to refine some of the issues on the surface detail. Also, the experimental carry frame setting is not supported for template match, so we'll make sure to leave this disabled. Let's adjust our parameters a bit. Alpha point will bring a bit up again to 0.1, set the alpha rigid to 125, the alpha smooth to 200, we'll leave the match distance limit at 0.05, we'll raise the sample radius factor to 14. This could cause a lack of precision, but should increase the processing speed and surface stability. Now we're going to go through our list of problem frames and create new intervals to correct the issues. We only have a few problems that we identified in our stabilization review that will need to be addressed in template match. When we're looking to update our clip using template match, we'll want to start by reviewing the mesh in the clean stage. The cleaned stage is where template match will draw the reference for the mesh used as the keyframe. We'll want to take our time to pick the best reference possible to use as the keyframe when making decisions. The first segment we'll correct is frames 149 to 150. We noted that in the original capture, frame 149, the keyframe, has a small hole in the mesh in the actor's sleeve. We will create a new interval in the template match stage for frames 149 to 150. Frame 150 has consistent geometry in the sleeve. We will select frame 150 as the keyframe by clicking and dragging the keyframe indicator. Next, we will skip to the end of the clip to address the issues with the gun prop in the final two intervals. The gun is twisted and unstable on frames 229 to 230, 232 to 233, 235 to 236, and frame 237. We'll start by making intervals for each of the segments that have problem frames. Our first one is frames 228 to 230. Often, twisted and warped mesh after stabilization is caused by node placement. Because we raised the sample radius, there should be a decreased amount of nodes in the deformation process. This can lead to a lack of precision, but based off of the short segments, it shouldn't be an issue. Looking at the clean mesh, there aren't any glaring issues, and frame 229 looks pretty good, so we'll select that as a keyframe. Next, we'll move on to 231 to 233. Checking out the cleaned mesh for those three frames, the current keyframe does look like the best choice as the barrel becomes slightly bent in some of the other captured frames. So we'll leave this interval as is. For frames 234 to 236, we'll select frame 235 as the keyframe. For the final segment in this interval, 237 to 239, we can keep the same keyframe as before, frame 237. For the final interval, we're going to be fixing frames 252 to 257, 269 to 271. For the first segment, we'll create a new interval in template match. The larger sample radius and higher alpha point settings have worked well up to this point, so we'll continue using these parameters. We'll try processing the segment in two intervals, one from frames 252 to 254 and the other from 255 to 257. Looking through, the cleaned mesh on 253 looks like a good candidate for the first interval. And 257 looks like a good choice for the second. To address frames 269 and 271, we'll make an interval. Using the same parameters in template match, we'll pick frame 270 to use as the keyframe based off of the cleaned mesh. With our intervals ready, we'll execute the jobs. Taking a quick look at the results, we can see that the sleeve no longer has a hole in the mesh on frames 149 and 150. And the shape of the gun is far more consistent, no longer warping and twisting as the actor holds it up. Template Match is a powerful tool to use for fixing mesh issues like these. We'll save this composition as AC5 processed_template match. Next, we're ready to move on to texture transfer.